Hi, welcome to the introductory session of this programming language and C language in general. Okay, see, to use a computer, you require software applications. Using software applications, we run the computer. Running computer is nothing but we process data. To process data, we use computers. So what we human beings can do, they can be done by computers, but much better than us. The reason they can be accurate and they can do within no time. So because of that, we use computers these days everywhere. Okay, so whatever data you have, that has to be processed. For that, you require some software application. So computer is basically a human being without life, whereas a human being is a computer with life. Like that we can compare. Okay, so suppose you need to process data as a human being, you need to have a procedure. With the help of that you can do it. A procedure is nothing but how you solve the given problem. Accordingly, you are going to be solving it. So same thing happens in the case of computer. So computers use different applications to solve different problems there. To develop such applications, we need to use programming languages. Okay, so without programming languages, we cannot use computer, we cannot process the data. So using programming languages, we can be processing data. So when you process data, we get information. Data is basically, it is also called as information, but which has little meaning. But when you process the data, you get full meaning. So to do such processing, you need to have some kind of applications or software tools. For developing them, we use here the programming languages. Basically, programming is a process which puts an algorithm into a computer understandable format. So programming is nothing but a process which is going to convert an algorithm into a computer understandable format. So that particular process we call as a program. So the conversion process, the conversion of algorithm into computer understandable format is called as a program. A program is nothing but a representation of the solutions which we give to the problem. You may have a problem. To the problem, you give a solution. So the solution here program is nothing but a representation of that particular solution. Okay, to develop such applications, we need to have programming languages. With the help of that, we can do it. So there are two different types of languages: high-level programming languages and low-level programming languages. High-level languages are those languages like C, C++, Java, CSharp, COBOL, Pascal, Fortran. They are similar to English language. Just like English language, they actually, they look like English language. Whereas low-level languages, the low-level languages are machine equivalent representation of the code. So using low-level languages, also a computer program can be written. But as far as low-level languages are concerned, we have very little abstraction. So we have very little abstraction. Coding with low-level language is very, very difficult. So low-level languages, they can be called as machine languages or they can be called as assembly languages. So low-level languages change from one processor to another processor. So every processor has its own set of instructions. So using those instructions also, we can develop applications. So when you use low-level languages, you lose portability. Though the code is efficient, but you lose the portability. For different types of processors, you need to develop different types of applications. Okay, and you have to be very much skilled to develop such applications. You need to know the technical details of the processor and its language. So it is very, very difficult to code with the machine or assembly languages. To overcome the problem, these high-level languages were in fact invented. So since 1946, there have been different generations as far as computer programming languages are concerned. We have like first generation languages, then second generation, third generation, fourth generation languages. So as far as first generation languages are concerned, they were called as machine language. So using various switches inside the computer, so the computer used to be programmed. So something like with ENIAC, what it was done in late 40s. But soon after that, the computer scientists found it very difficult to code, to develop applications with the machine language. To overcome the problem, they invented assembly languages. But assembly languages are machine specific. See, the programmer cannot have good productivity when the person is using assembly language. Of course, the code can be very short, so only in few KBs you can finish it. So it's going to be more and more efficient, but you don't have portability with the assembly language. So therefore, to overcome the problems of the assembly language, the high-level language like third generation languages, they got developed. COBOL, Fortran, BASIC, they were the high-level languages which got developed during 60s. COBOL is common business-oriented language. For business applications, COBOL is used. When we take Fortran, Fortran is basically formula translation. In scientific applications, we can use them. Again, these languages are very, very difficult to learn and very difficult to develop code using them. Okay. And one other type of language people had, that was basic language. Basic stands for beginners all-purpose symbolic instruction code. Basic can be, you can code using basic very easily. Learning basic language also very easy. Using that also is very, very easy. But industry strength applications, robust applications, we cannot make with the help of the basic language. That was a drawback with the basic language. So to overcome limitations we had with these languages, C language was invented in 70s by Dennis Ritchie. Dennis Ritchie and Ken Thompson together, they developed Unix operating system that was totally written in the C language. The reason for developing C language was necessity of an operating system to run a Star Wars game on the PDP-11 machine. So prior to PDP-11, it was PDP-7 machine. On that, they had a game called as Star Wars. So that was a wonderful game. After, when new machine like PDP-11 came into existence, so again, the Star Wars program had to be rewritten there. So to overcome such portability problems, they invented, in fact, the C language. So using C language, they invented Unix operating system. So in the Unix operating system now, use the Unix, as you know well, it's a multi-user operating system. It's very much widely used. Okay, so this was the reason for developing C language. That got developed in 1970s by the great scientist called as Dennis Ritchie. So Dennis Ritchie developed C language because of a single person who involved in developing C language. Still, it is an unbeatable language. See, even in these, modern age, when compared to 70s, definitely this is modern age. So in this age also still, people use C language to develop different applications. Okay, even still we use C language sometimes to develop applications which are machine critical and time critical. Okay, so because of these reasons, C got developed. But C is actually what? A procedural language. C is a very high level language, but it is a procedural language. Again, when you take third generation languages, we had there a imperative language, a functional programming language, and logical language. Or we can say imperative languages, functional languages, and logical languages. As far as imperative languages are concerned, so under that we have procedural as well as object oriented. So procedural languages are something like C, COBOL, Pascal. These can be called as procedural languages. Whereas C++, Ruby, Java, C#, VB.NET, these are called as object-oriented programming languages. Similarly, we had other types of languages like functional programming languages. They rely on the mathematical functions. So the famous functional programming languages are Lisp, and in recent times, Microsoft developed a language called as F Sharp. Okay. Similarly, we have logic-oriented languages, something like Prolog. With the help of that, we develop artificial intelligence-based applications. So these are basically high-level languages, and these high-level languages provide a lot of abstraction for us. So the internal machine is totally hidden for us. How internally things are happening, we do not bother. Without bothering much about that, with the help of these languages, we can develop applications. I mean, very quickly with few errors. So this is the advantage with the high-level languages. These high-level languages provide us a lot of abstraction. So internally, how things are happening, a programmer need not know. So if the programmer knows about the high-level language, comfortably the applications can be developed, and these are not error-prone when compared with the assembly language or machine language. Okay, so with the help of these high-level languages like C language, we can develop applications very fast. So here, the productivity of the programmer is improving very much. Okay, so C is what exactly? It's a compiler. When we talk about high-level languages, again, here high-level language has to be translated to machine understandable format, because computers can work only with a binary code. But whatever code you write is in high-level language. Something like English only, it looks like English. So using these high-level languages, we write code. So the code, whatever you write in high-level language, cannot be, executed by the hardware. So for that purpose, we need to convert that into machine understandable format. For that purpose, either we need to use a interpreter or a compiler. Okay, we require here the language translators called as interpreters and compilers. If you take high-level language like BASIC was an interpreter, whereas COBOL was a compiler, Fortran was a compiler, C is also a compiler. BASIC is what? It's an interpreter. Whenever you execute a basic program, line by line, it gets executed. To execute a basic program, behind the application, you need to have there a interpreter, which also should be running parallelly along with the application. So if the interpreter is not available in the target computer or in the user computer, the application cannot be executed. So this kind of translation process is called as interpretation. So line by line, it executes the code. Code gets executed line by line. So this is going to be a little bit slow when compared with the compilation. But languages like COBOL, Fortran, they in fact compile the given source code into object code or machine understandable format they convert. Languages like COBOL, C, Fortran, they compile. So in the case of compilation process, the input, the source language is taken and that's totally translated into machine understandable format. So compilation process is going to produce better output in the sense it gives us actually object code. So at one time only this process takes place. So once compilation process is over, straight away you can execute. So in the target machine or in the user machine, we don't require compiler. When an application is getting developed, at that time, we need to have the compiler. But once application is done, since the compiler is going to convert the given application or given source code into machine understandable format. Once that is done, no longer we require the compiler. So this is the advantage with compiler. See, I would like to give an example, real world example for compilation as well as for interpretation process. So normally the country's presidents or prime ministers, they address the nation on the occasion of the Independence Day or some Republic Day or some important events in their country, they try to address the nation. So when they address the nation, what happens actually, that is broadcasted live. Okay. Throughout the country, if they use one language, there is no problem. Since all the people speak same language, they can hear it. But countries like India, you take, here different languages are spoken. Few people speak Hindi, and few speak actually Tamil. Few speak Malayalam and Punjabi. Like that, number of languages are spoken. Okay, so I mean, all the people may not be knowing this Hindi or English. So normally, president or prime minister address the nation either in English or in Hindi. So once it is completed, again that is translated into here the local languages. Then that can be broadcasted. Once the translation is over, no longer you require the source speech. Once the speech is translated into the local languages, no longer we need the original speech. So this process is called as here compilation. So once we translate the source speech into the native language, no longer we require whatever is translated, that can be played a number of times. So that can be broadcasted a number of times without requiring the original speech. This process can be called as a compilation process. So total speech is translated into other languages. So once that is translated, we don't require the original speech. This you can take as an example for the compiler. Similarly, we take interpretation, another example for interpreters. Normally, the political summits or summits related to other major events, they take place, and the heads of the countries normally they participate in that. For example, we take one such summit on the World Health. So for example, take related to healthcare. There may be a summit which is being conducted. In that, different presidents they may participate. A French president, a Russian president, and American president, they are participating in the summit. So here, the talks are trilateral. It's not bilateral. The talks are trilateral. All the three presidents, they are discussing something. So when they discuss something like that, what normally happens? American president speaks in American language, French president speaks in French language, and Russian president speaks only in Russian language. So whenever they are discussing something to convey what American president is saying to the Russian president in Russian language, some kind of translator is required there. So that word can be called as interpreter. So whenever they are discussing something like that, always a translator is required there. Otherwise, the communication cannot take effectively there. So this kind of process is called as here interpretation. So this kind of process we can call as interpretation. So languages like BASIC are called as interpreters. These days everywhere we use browsers. In those browsers also you have this kind of interpretation. So that is like JavaScript. We use JavaScript, we use VB script. So these are called as interpreters. They are going to interpret line by line. At one time only, one line can be executed. So as long as they don't encounter an error in the code, they never offend. But in the compilation, at the time of compilation itself, they are going to give you the list of errors. At the time of compilation itself, they can find out what kind of errors it's going to contain, the program is containing, so it can list, it can rectify them, then once again recompile. But in the case of interpretation, there can be few errors in the code. Unless you execute, you cannot understand about that error. So like this, you have interpreters as well as compilers. But C is what? C is a compiler. C is nothing but it's a compiler. You write source code in the C language, then with the help of the C compiler, we translate that into machine understandable format. So machine understandable format may be like object files, we say object files, or they can be say like exe files. We say it as execution files. You can say this as here execution files. So object files have an extension dot here dot obj, whereas execution files they have an extension dot exe. File name extension is going to be dot exe. In the case of translated code, whatever source code you have, you can translate into either object code or exe file. So exe files are basically they can load themselves, they can start the program getting executed. But object files they are not like that. They cannot link themselves and they cannot load themselves. So exe files are called as actually linkage loaders. So they can be linking themselves. They can link different modules of the code. Similarly, automatically program can load itself into computer memory. See, to run any program, first of all you load into memory, you have to load into memory, then you can execute. Because here we follow a stored procedure concept, it's under one Newman model. So in the one Newman model, what happens? Before you execute any program, you need to put into computer's memory, then you can execute. See, whatever type of program, suppose you start a browser, something like Chrome. First of all, you need to move the Chrome application into computer memory, then you can execute. You are starting MS Office. When you start MS Office, you move into first of all memory, then you can start executing MS Office. So physically, first of all, you have them on the disk. From disk, you move into computer memory, then you start executing. So that's why these today's computers, whatever laptop or desktop we use, they are called as general purpose computers. That means different types of applications you can run. Sometimes some graphics applications you can run. Sometimes you can open a browser. Sometimes you can start MS Office. Okay, sometimes you may be opening CAD application, something like computer aided drafting and designing like that. So different types of applications you can be loading and you can be running. So that's why we call it as general purpose computer. In contrast to this, you take embedded systems. Embedded system meaning is you develop a program and you put into the chip there. So it's basically made for a special purpose. For a particular purpose only you write code, and for that particular purpose only always it's going to work. So you cannot load whatever program you want to load into that. It's not actually general purpose, it's a special purpose. So when you take the embedded systems, it's called as a special purpose, code that is. Whereas whatever code you write can be here a general purpose. Your computers are not basically general purpose computers. So different types of applications you can be running it. To develop such applications, you need to have language like C. C is a high-level language. Using C language, you can develop any kind of application. So it's made for any kind of application. Whatever application you want to develop using C language, and whatever application you want to develop, you can develop using C language there. So, like our natural languages like English or French or German or Spanish. So here, these languages also have certain character set and they have the parts of speech. So take example English. In the English, first of all, we have a character set. It's nothing but alphabets A to Z. And sometimes we use some punctuation symbols like a semicolon, you use sometimes a comma. So these can be called as punctuation symbols. Similarly, if you want to deal with some kind of calculations, you may be using something like plus, minus, multiplication, division. So all these symbols are available in our languages. So same thing happens with the computer languages. So computers also, the language like C supports the different characters like, these are called ASCII characters. For them the values can be from 0 to 55. So internally everything inside the computer is a number. So Equal to them, you have the characters. It supports actually 0 to 255 characters as far as ASCII is concerned. But modern C supports Unicode characters. Using that, you can represent any language which we are using in the world right now. So C supports Unicode as well as ASCII. In fact, ASCII is a subset of the Unicode. If you take the ASCII characters, they are nothing but subset of the Unicode characters. So using ASCII characters, you can write the words in the C language. So these words can be called as here tokens. In our English, we have something like parts of speech. We say noun, we say pronoun, we say verb, adverb. So they are nothing but different types of words you form using the alphabets there. Few words which you form may have a predefined meaning and few may not have predefined meaning. You may form your own words few, they can be called as identifiers, and they may be few words which have already some meaning. So like this, you can form different types of words with the help of the characters available in our natural language like English. So same thing happens in the case of computers. But as far as high-level programming languages are concerned, particularly if you take C language, it contains 4 different types of tokens. Those tokens are going to be identifiers, operators, separators, and keywords. So keywords are going to be reserved words. So compiler has reserved those words for certain purpose. So for the intended purpose only, you must use the keywords. Take example, see English language. In the English language, we have certain helping verbs, say is, was, has, have, then had, am, or were, or all these are nothing but helping verbs. They have some predefined meaning. For that purpose only use it. For whatever purpose you want to use, it is not allowed to be used. If you try to use like that, grammatically it becomes wrong. Okay, so same thing happens in the C language with the keywords. Keywords are nothing but reserved words which have a predefined meaning. For that purpose only, we must use the keywords. So keywords are predefined words which have a meaning. For the intended meaning only, you must use those keywords. C contains, different set of keywords. There are about 32 keywords in the C language. They have some intended meaning. For the purpose only, for the intended purpose only, you must use. They have already predefined meaning. So for that purpose only, you must use the keywords in the C language. And we have other types of token called as identifiers. An identifier is a word which is invented by user. So something like a variable name, a constant name, a method name, or a function name. So a structure name, a union name, these can be called as identifiers. User invented, just like our names, or things names, or rivers names. So all these are what exactly we are going to define them. People's names are defined by us. So these can be similar to them in the C language. We have there the tokens called as identifiers. But you need to follow certain rule in that. You need to follow certain rules. So whenever you try to make an identifier, you have to use first of all an alphabet, followed by either you can use a digit or alphabet or underscore. So like that, we can be defining their identifiers. Similarly, we have there the operators. See, when you take a programming language, you can perform different types of operations. They can be arithmetic operations, they can be some other types of string manipulation or number manipulation, even some other things also you are going to do. For doing such things, you need to have some kind of predefined operations. So that you can do with the help of the predefined operators like arithmetic operators, relational operators, logical operators, then similarly a conditional operator. Okay, so any equality operator, inequality operator, like increment operators, decrement operators, ternary operator. Like that, we have different types of operators in the C language. Using them, we can perform certain operations, and these operators may accept only one operand or they may accept more than one operand also. For example, you write minus a. In the case of minus a is called as operand, minus is going to be called as their a operation or operator, that is. You are negating the value of a when you write minus a. So minus is nothing but an operator which is going to have some operation on the given data. We take only one set of data. That data is now called as operand. So such things are called as unary operators because they use only one operand. Similarly, you write sometimes a plus b. A is a number, b is a number. When you write a plus b, a is called as one operand, b is called as another operand. You try to perform there an arithmetic operation on the given a and b. So plus is what here? A binary operator. So like this you are going to have ternary operator and quaternary also you can say, or n-ary operator. Like that you can be having. So the different types of operators, they may accept only one operand or more than one operand. And next thing is going to be separators. So using separators, you may terminate a statement or you may separate the arguments you are passing to a function, or while declaring variables also at one time only you may declare more than one variable. To separate them also you can be using comma. So like this we have the separators also. So these four, they actually make the C language program. With the help of these four different types of tokens, we write the C language code. So the C language is containing here the tokens. The tokens are what exactly? A identifier, a keyword, an operator, as well as separator. So with the help of that, we write the C language code. To write C code, we require these things. So using any text editor, something like Notepad or TextPad, or you can say any other editor, you can write code. So once you write code, you need to save with a .c extension. After that, you need to compile it. For compiling, you require a C compiler. Using a C compiler, you can be converting that into machine understandable format. Because what you are writing is in high-level language. The processor cannot understand whatever you are writing in high-level language. So you need to translate this into machine understandable format. This process is called as here compilation. But in the case of low-level languages, what happens? Whatever code you write, they may not require any compilation, or even they require a little compilation can be taking place in that. So but here, what happens? In the case of high-level languages, definitely we need to translate. Either that can be compilation process or that can be interpretation process. Okay, so depending on the design of the compiler or design of the programming language, it's going to be working that way. So either compilation or interpretation. So either it can be compilation process or it can be interpretation process. So depending on the application requirements, normally they get developed. Okay, so C is what therefore is a compiler. Using these tokens, you write a C source code. Once you complete writing a source code, you need to compile it. When you compile, if it's having any errors, they are going to be listed. You need to clear the errors. Then again, when you compile, when it does not find any error, it gives you a object file as well as exe file. You can execute them on the target machine. So like this, normally the translation process takes place. So in C language, this way the language translation process is going to be taking place there. So we have different types of C compilers. GCC compiler is available. Similarly, Turbo C compiler is available. Microsoft C compiler is available. Daylight C is available there. Like that, we have different types of C compilers. Using C compiler or using C language, either you can develop system software or you can develop application software. What you can do with assembly languages, you can do with the C language. Or what you can do with the Java or CSharp, you can develop even such applications. C is a general purpose programming language. C is a general purpose programming language. Okay, so using C, you can develop any kind of application. The limitation is only with you, it's not with the programming language. Whatever you want to do, you can develop a C language. You can develop applications which can be running on the network, or it can be standalone computer, or they can be for the mid-range computers. Even for supercomputers, you can develop applications using C language. These days, actually, everywhere people are using parallel computers. To develop even parallel computer-based applications, you can use C language. But you need to have them, you need to have their separate types of compilers. They are going to be basically C, but to meet the requirements of parallel computing, some extra features are required. Using them, you can develop applications which can run with the parallel computing mechanism. So, therefore, here using C language, you can develop any kind of application, command line applications, console applications, web applications, even Windows applications also you can develop using C language. That much powerful is C language. But unfortunately, these days mostly people are using very high level languages like C# or Java or VB.NET or Ruby. With help of that, they are developing. So to develop applications with C language, you need to be more and more skillful. It is really not a basic language. People think that C is a basic language. It's really unfortunate to think like that. C is not a basic language. It's very much advanced language. C is a base language. So C is really a base language, but not a basic language. Everyone cannot do with the C language. It's not so simple actually. Of course, you may write few programs in C, but that's not everything. With C, you can do wonders. Okay, so real-time system software is developed using C language. System software is nothing but which drives the hardware. The operating systems you take, that's nothing but actually an application written in the C language. Similarly, you may have some drivers. Those drivers, they get developed by the C language. Audio drivers, microphone driver, speaker driver, disk drives you take, disk drivers are available, video drivers are available. All these are done with the help of the C language. In fact, they are written in the C language. So C suits actually for the system programming. It's very good to develop system software with C language when compared with any other language. At the same time, you can develop high-level applications also with the C language. Because using C language, you can access the internal resources of the computer. Because of that feature, C is used for developing, the system software. It's called as actually in that case, low-level program you can do with the help of the C language. Normally to access computer resources, you need to have the computer resources at the low level, you need to have their either assembly language or machine language. Suppose you have to access CPU registers. How do we access? So with the help of the C language, you can access it. See, whenever you take the computers, the hardware, I say the processors, inside the processor, we have ALU, arithmetic and logic unit, then you have a control unit, and one more thing is here, ALU registers. So those registers are normally called as, AH, in the case of Intel I am saying, AX, BX, CX and DX, you have AX registers, BX registers, CX registers, similarly DX registers. You can access them with the help of the C language. Using other languages straight away, you can't access. So similarly, you can access the memory. To access memory, you have pointer mechanism. With the help of that, straight away you can go to the memory. If you want to modify any content, you can modify. So like that, C is so powerful, it can access the resources of the C, internal, which are abstracted for high-level languages, can be accessed using the C language. So because of that, most of the system software gets developed using C language. Okay, so using C, you can develop virtually any kind of application. It can be, system software, or it can be application software. But for developing such applications, we need to have a C compiler, as I told. That can be a GCC compiler, or it can be a Turbo C compiler, or Microsoft C compiler, or it can be Dev C. So in the Dev C they are using here, it's an IDE. Dev C is an IDE. So TDM GCC is used here. Dev C is nothing but it's a IDE, integrated development environment. Using that very quickly, we can develop applications. IDEs help us in developing the applications. When you work with Microsoft C, you have Visual Studio. When we work with when we work with this TDM GCC, we can use the Dev C++. In the case of Turbo C, you have an editor, Turbo C editor. With the help of that, you develop applications. So using these compilers and using these tools, you can develop applications. They help you in developing the applications. If you write something wrong, they can show you some warning. So even compilation process is going to be very easy because in the same IDE, you have an editor. Using editor, you can edit code. Once it's completed, you can save it as a file. So once you save the file, from here itself you can compile it. Once compilation is successful, you can test whether it's working perfectly or not. Okay, so in this process, if you need any help of the command, you can get the help of the help available here. So like this, we have IDE. Using IDE, very quickly, we can develop the required applications using C language. So C is what, therefore, it's a high-level language. At the same time, you can develop system software as well as application software using C language. So using C language, you can develop those. So similar to C, we have other languages like C++, which is just extension to C language, but object-oriented. There you have classes, objects. C++ is going to be an object-oriented language. But it's not compulsory. You have to develop only object-oriented languages, object-oriented applications using C++. If you want to use it like C, you can use like C, or you can develop object-oriented applications using C++. So similar to C++, we have Java as well as CSharp, but Java and CSharp very high-level languages, unlike C++ and C. So using C++ and C can be working sometimes as low-level languages, but Java and CSharp, they are really high-level languages, but they belong to the C family of languages. They belong to C family of languages, both C, C++, Java, CSharp, JavaScript, Ruby. Syntactically, they look similar. Syntactically, they are going to look similar. C syntax, C++ syntax, Java syntax, C-sharp syntax, then similarly JavaScript syntax are going to be similar. Even Ruby syntax is also to some extent, it's going to be same. PHP, we have one web-based application development language. Even PHP syntax is also going to be same. So syntactically they are same. They belong to the C family of languages. Okay, so what is the syntax? Syntax is nothing but the way of writing the sentences can be called as syntax. It's nothing but grammar. How in English we use different words, different verbs. So how we use subject, object, then verb. So for that you have a particular pattern. In that pattern only when you write grammatically that's correct. Same thing in the case of C programming language also. Whenever you write any statements or any sentences, you must be writing it the proper way. Otherwise, compiler can't understand. That part can be called as in fact syntax. So the syntax is going to be same in all these languages. Even other features also, object-oriented features, if you take the C++, is similar to Java as well as the C Sharp. So C Sharp and Java almost you can say similar languages, but C++ has some minor difference with the Java and C Sharp. C++ supports multiple inheritance, Java, C Sharp does not support. So like this you have minor differences. So this is basically the introduction to C language, and we covered something related to say low-level languages, high-level languages, then what is translation, what is interpretation, what is compilation. We have seen those things. So tomorrow we are going to discuss about the data types of the C language. Thank you very much.